Good morning, afternoon, or evening. Welcome to Mr. Morrow's intensive math class. This year we're going to be focusing on the basics and making sure that you know how to do everything that you need in order to succeed in higher level mathematics courses. Today we're going to start by classifying numbers in the real number system. Now, you can classify numbers using what's called sets. Okay? Sets. A set is a well-defined collection of objects. So you can have, for example, in your drawer, you may have 5 different types of team shirts. That's a set of team shirts. Okay? Then you may have a set of socks. Okay, you have a number of socks. That's a set of socks. Okay, you can have in your closet maybe 5 pairs of pants. So you have a set of pants. Okay? So a set is a well-defined collection of objects. Numbers work that way as well. Each object is called an element of the set. And a subset of a set consists of elements from the given set. For example, if I have the set 2, 3, 5, 8. Okay? 2, 3, 5, and 8 are all elements of the set. But I can make a subset, and I can say the subset of set A, I want it to be the odd numbers from set A. So my subset would be 3 and 5, because that is basically a part of one set. Now, you can list the elements of a set within something called braces. I'm not going to get too crazy on sets and subsets, but the reason I brought this up was because the real number system is made up of sets and subsets. The main picture, the big picture here, is real numbers. And basically, my friends, real numbers literally are any number. Okay? Any number. So on a number line, everything is included in real numbers. I'm talking positive numbers, negative numbers, fractions, decimals, perfect squares, non-perfect squares, irrational numbers. Any number is a real number. Now, as you keep going on in math, you are going to find out that there's something called an imaginary number or a complex number. That is not a real number. Today, we're just going to deal with a set of real numbers. So a real number is any number, okay? Now, natural or counting numbers. Natural or counting numbers, my friends, are whole units starting with the number 1. There are no fractions and there are no decimals when you're talking about natural or counting numbers. They are only numbers that are whole units starting with 1. So for example, if we look at the natural numbers on a number line, we're talking about 1, 2, 3, 4, 5, ... All of the whole units starting with and including 1. Now, those are natural numbers. Whole numbers. Whole numbers are, again, whole units starting with and including 0. There are no fractions and no decimals in whole numbers either. Whole numbers are whole units starting with 0. No fractions and no decimals. So whole numbers on a number line would include 0, 1, 2, 3, 4, 5, dot, dot, dot. Okay? These are whole numbers. So far we've seen real numbers, which is any number, natural numbers, which are whole units greater than or equal to 1, and we have whole numbers, which are whole units greater than or equal to 0. In other words, starting with 0. No fractions and no decimals are in natural numbers or whole numbers. Number 4, integers. Integers, my friends, are whole numbers and their opposites. Believe it or not, 0 is an integer. Why? Because 0 is a whole number. So when you think of integers, okay, we're talking about whole numbers like 0, 1, and their opposites. -1, 2, -2, 3, -3, 4, -4, 5, -5, etc., etc. Integers are whole numbers and their opposites. Whole numbers and their opposites. Okay? Okay? Does that make sense so far, gentlemen? Awesome. Okay, now, here's the big boy. Remember that I told you real numbers are any number. It's a pretty large category. However, rational numbers are a pretty large category as well. Rational numbers is any number that can be written in A over B, or in other words, in fraction form, where B, which is the denominator, cannot equal 0. What do rational numbers include, you may be asking? Well, they include natural numbers. Because, for example, 3 can be written as a fraction, 3 over 1. They include whole numbers. Why? Because, for example, 12 is a whole number, which can be written as a fraction, 12 over 1. Integers are rational numbers because, let's say, -5, I can write that as -5 over 1 as a fraction. Any fraction is a rational number. Any mixed number is a rational number. Terminating decimals. Terminating decimals are decimals that have a final end. For example, 0.25 or 0.375 or 0.17. If the decimal number ends, it stops, then that is called a terminating decimal. Rational numbers also include repeating decimals. Repeating decimals are things such as 0.45 repeating, or 0.3 repeating, or 0.72 repeating. That little line on top of the numbers when you're dealing with decimals indicates to the reader, hey, dude or dudette, this number is always going to be repeating. So again, rational numbers are any number that can be written in fraction form. They include natural numbers, whole numbers, integers, fractions, mixed numbers, terminating decimals, which are decimals that end, repeating decimals, which are decimals that repeat, and last but not least, perfect squares, such as the square root of 4, or the square root of 100, or the square root of 81. All of those are perfect squares because they equal a whole number, so therefore they are rational. Does that make sense so far, gentlemen? Okay, thank you so much. Let's look at some examples of rational numbers. Examples of rational numbers. -5. What kind of a number is -5? Come on, guys. What kind of a number is -5? That would be an integer. Very, very good. How about 3.775? That's rational as well. Very good. How about -1.535353? Rational. Very good. What about this fraction? It's rational, absolutely. And square root of 144 equals 12, and that's a whole number, which is also a rational number. Does that make sense, gentlemen? Awesome. Okay, very good. May I continue, boys? Okay. Now, irrational numbers. An irrational number, okay, are numbers that cannot be written in A over B or fraction form. They cannot. Irrational numbers cannot be written in fraction form. Irrational numbers include, number 1, non-terminating or repeating decimals. Non-terminating and non-repeating. For example, pi. Pi is non-terminating and non-repeating. For example, look at this number. 1.232256556235662 ... It does not repeat and it does not end. That means it keeps going on forever. So that is an irrational number. And the other kind of irrational number includes a non-perfect square, such as the square root of 32 or the square root of 15. If it is not a perfect square, it is an irrational number. Does that make sense so far, gentlemen? Yeah. Well, guess what? That's the lesson. Let's go ahead and practice. Okay? Let's make this easy for us. Let's say, it says here, identify which types of real numbers each of the following represents. If it's rational, let's call it RT. Whole number, let's call W. Natural number, let's call N. Irrational, let's call IR. And they are all real numbers because I said that they're all real numbers. Okay? So, 2.6. Which category or categories would 2.6 fall under? Sir? It is irrational. Very good. And only irrational. Because it's not a whole number, it's not a natural number, and it's not irrational because the decimal ends. How about number 2, -8? What kind of numbers would that fall into? What sets would that fall into? An integer? Also? Oh, wait, we forgot integer. Let's just make that an I, sorry. So integer, and what else? There's one more that it would fall under. What else do integers belong to? Yes? Rational number. Very good. Very good. How about number 3, 15? That would be rational. What else would it be, my brothers? Whole. What else? They're all real. Natural. Very good. And isn't an integer the whole number and its opposite? So this is also considered an integer. So the number 15 can be rational. It can be a whole number. It can be a natural. Or it can be an integer. It can fall in any of those subsets. How about the square root of 81? What's the square root of 81 equal? Well, what does it equal? 9. Very good. So what kind of category would 9 fall into? Rational, integer, whole, and natural. Excellent. Excellent. How about number 5? Rational. Very good, sir, because it is repeating. Can it fall into any other category besides real? Okay, you say yes. What other one? No, it can't, right? Because repeating decimals are only rational. It's not natural or whole. How about 0? It's rational, whole, integer. Is it natural? No. Very good, very good. How about 2.78? Rational. Would it fall into any other ones besides real? No. How about 22.36872 keeps going on? You guys are quick. Awesome. Irrational. Because the decimal does not end and it does not repeat. How about square root of 7? Irrational. Is that a perfect square, my man? No. So that would be an irrational. Excellent. How about 33 1/4, number 10? Rational. Very good, because it is a mixed number. Excellent. Excellent. How about negative 12? It is an integer. Very good. It's also rational. Yes. Anything else? Could it be whole? No, because whole numbers are greater than or equal to 0. It's an integer, but that's about it. Okay? And what about, last but not least, number 12? It's pi. Irrational. That's exactly correct. Irrational. Does that make sense, my brothers? Guys, I hope you enjoyed the lesson and I hope you learned a lot. Thank you very much and have a great day.